Now we're going to learn how to create a confusion matrix in R using the tools we've already created. We've created a list of predictions from the training data and a list of actual values from the training data. We've created a list of predictions from the test data and a list of actual values from the test data. And remember, a confusion matrix is just a summary of how many predictions were 0 and how many times were we correct about those predictions, and how many predictions were 1s and how many times were we correct about those predictions. So we're really just counting when things matched. So an example of that would be length, because I'm counting, which, because I need to identify a specific set, train pred equals 0. And remember, we use a double equals when we're testing to see if something is equal. The ampersand acts as an AND operator. And then we'll compare train actual equals 0. This line of code is going to count how many observations of train pred were equal to 0 and train actual were equal to 0, meaning how many times did I predict a 0 and actually experienced a 0 in the data. When I run this line of code, I'm going to get a number. It's 172. So out of the entire sample size, which is the dimensions of the training data, out of 7,877 observations, 172 times I predicted we would get no donation, and we actually got no donation. So I can copy this code several times and edit. In the second line, I'm going to put a 1. When did I predict a donation? And a 1 in train actual will say, when did I actually get a donation? But then I'm going to want to understand when I made mistakes. So when did I predict a 0 and received a 0? When did I predict a 1 and received a 0? I'm sorry, when did I predict a 0 and received a 1? When did I predict a 1 and received a 0? So I'm looking at the 4 possible combinations of predictions and actual values. When did they match? When did they not match? And what were the possibilities for their not matching? Now I'm going to run the last 3 lines that I haven't run yet. And I see that I get counts for each one. So look here at the 7,431 observations. Seems to be very common that I predict we get a donation and we actually do. That's really exciting. And then 56 times I predicted we did not get a donation, but we did. And 218 times I predicted that we did get a donation and we did not. Now, that's 4 lines of code. There's actually a faster way that I can do this that's only slightly harder to understand. But I wanted you to see exactly what we're doing with the simplest possible functions first. Now I can get all of those answers in one line of code. CFM, for confusion matrix, is going to be equal to something with the aggregate function. Remember, the aggregate function can count or take means within different groups. So I'm going to count up train pred, and I'm going to do it by 2 variables. Train pred and train actual. And that's going to say, organize things into the 0s and 1s for train pred, and at the same time the 0s and 1s for train actual, and count how many are in each of those combination groups. So when I run this, nothing will happen because I've stored that result in CFM, but let me print out CFM. You can see that we have 0, 0, 172. The same we had up here for train pred 0 and train actual 0. So it's counting how many train preds were equal to 0 while simultaneously the actual value is 0. So this says, when did I predict a 0 and receive a 0? 172 times. Now to make life easier, I'm going to relabel the column names. And this is the first time we're using the call names function. And I'm going to say, the first column label should be the first thing that I organized by. So it should be train pred. And the second should be the second thing I organized by. And the third we'll call count, because that's going to be the count of how many times this happened. So now when I print CFM, it'll have nice column names. So now this says when I predicted a 0 and when I actually got 0, that happened 172 times. Now, counting is not always a nice, easy way to look at things, because what I really want to know is what is the percent of times that something happened? Because percentages can always be interpreted simply, because I know the best is 100%, the worst is 0%. So I want to turn these into percentages. And the way I'm going to do that is I'm going to edit CFM to divide by the sum in the third column. So I'll say CFM is going to equal, CFM third column is going to equal the CFM third column divided by the sum of the CFM third column. So what this line of code is going to do is say, take each entry in that third column. So trying to highlight, take each entry in the third column and divide it by the total of the third column. And obviously that's how we calculate percentages, but then it's going to store that number in that third column in each space. So when I run this line of code, nothing will happen because it's just going to store CFM again. But when I print out CFM, now I have percentages. So I can see that 94% of the time I predicted there would be a donation, and there was. And less than 1% of the time, 0.007, I predicted there would be no donation, and there was. I'm going to do the same thing in the test set. So I'm going to create another CFM, CFM2, and I'm going to say aggregate train test pred by test pred and test actual. And I'm going to count them up again. Call names CFM2 will be test pred, test actual, and count. And CFM2 third column will be CFM2 third column divided by the sum of CFM2 third column. So I'm just doing the same three things, but calling it CFM2 instead of CFM1. When I run this, nothing will happen, but when I print out CFM2, I'll see my test set evaluation. So think of this as exactly like when we looked at an error distribution for a training set and a test set when we looked at linear regression. Now I'm looking at an error distribution, but the errors are different. I'm summarizing them in a confusion matrix. Now, when I present these numbers to my manager or to someone that I'm trying to convince of something, I don't want to show them this R output. It's very messy, it's very confusing. They would say, what's test pred and why is it in a PowerPoint presentation? What they want to see is something that's formulated in a way that's easy for them to understand immediately. So that's what the last video is going to be about, interpreting these results and displaying them in a meaningful way.